architectural acupuncture for the planet. Small strategic interventions across different sites can collectively restore ecological balance, strengthen communities, and reconnect fragmented urban systems. Instead of approaching climate resilience only at massive scales, the program explores how localized design interventions, data-informed planning, and digital twin technologies can create meaningful transformation one site at a time. The vision asks an important question. What happens when students across Los Angeles are given access to professional tools, collaborative mentorship, and real environmental challenges to solve? The result is a learning ecosystem where students are not simply studying cities, they are actively modeling, documenting, visualizing, and redesigning them. Digital twins serve as the connective framework behind this process. A digital twin combines spatial data, environmental systems, visualization tools, research documentation, and interactive media into a living representation of a site or urban condition. These systems allow students to analyze infrastructure, environmental performance, public space, mobility systems, climate impacts, and social conditions simultaneously within one interconnected platform. Through this framework, students learn how architecture, ecology, data systems, public policy, visualization, and storytelling all influence one another. Helping make this vision possible is the collaboration between the California Center for Climate Change Education, the LATTC Architectural Technology and Environmental Design Program, and a growing network of institutional, environmental, and industry partners. Together, these organizations create pathways for students across the Los Angeles Community College District to participate in paid internships, interdisciplinary research, and climate-focused workforce development. Shade LA is a citywide environmental resilience initiative focused on identifying heat-vulnerable areas across Los Angeles and developing equitable cooling strategies through digital twin technology. Using NASA EcoStress thermal data, GIS systems, Power BI dashboards, Unreal Engine environments, React interfaces, and environmental simulations, students visualize urban heat island conditions, canopy coverage, and neighborhood-scale cooling opportunities throughout the city. Another major initiative centers around U.S. Green Building Council California's Rebuilding LA work, focused on wildfire resilience, post-fire recovery, and regenerative rebuilding strategies for communities such as Altadena following the Eaton fire. Using Unreal Engine, Rhino, GIS systems, XR workflows, and environmental simulation tools, students model resilient neighborhoods, modular ADU typologies, wildfire-adapted infrastructure, and future rebuilding scenarios. The Pandopopulous Ecological Digital Twin Initiative focuses on creating highly detailed environmental models of biophilic and ecologically sensitive landscapes using Rhino, Unreal Engine, Lands Design, GIS systems, Polycam scanning, LiDAR processing, and immersive XR workflows. Developed in collaboration with Pandopopulous and UCLA Extension, the project explores how digital twins can support ecological education, vegetation analysis, regenerative landscape planning, and public interaction. The Pico Union Housing Corporation Innovation Alleys project explores how underutilized alleyways throughout Pico Union can transform into eco-cultural corridors that support biodiversity, environmental performance, public gathering, and community participation through digital twin technology. Using environmental APIs, interactive maps, browser-based co-design systems, Unreal Engine visualization tools, and real-time environmental data, the project allows residents to collaboratively redesign alley spaces while visualizing environmental impacts such as air quality, shade coverage, biodiversity, and cooling performance. The Baldwin Hills Corridor project introduces data-responsive design frameworks, developed in collaboration with the Baldwin Hills Conservancy and Aura Environmental Systems. Using GIS systems, Grasshopper workflows, Rhino, LiDAR processing, flood risk analysis, and environmental simulations. Students transform environmental data into active design parameters that influence ecological performance and spatial decision-making across the 6-mile Baldwin Hills corridor. The ASU Reclamation Project focuses on underutilized urban sites such as Lenox, using immersive XR tools to activate space, support environmental education, and invite students and neighbors to continue imagining and redesigning the site collaboratively. Using Unreal Engine, Rhino, Cesium, Twinmotion, VR workflows, environmental simulations, and interactive media systems, students are building immersive experiences where users can engage with ecological systems, environmental narratives, and digitally reconstructed landscapes. Another important layer of the fellowship emerged through a future visioning collaboration led by Kathleen Cohen and Shiraz Makarechi, explored how storytelling, digital tools, ecological systems, and speculative design frameworks could help imagine more humane urban futures. Rather than treating technology as purely technical, this collaboration examined how visualization, immersive media, and narrative environments could help communities better understand invisible systems shaping Los Angeles, including environmental stress, mobility systems, public safety, ecological imbalance, and nighttime accessibility. Together, all of these projects form a larger ecosystem where students are not simply learning isolated software platforms or technical workflows. They are learning how architecture, environmental science, geospatial systems, computer science, storytelling, immersive media, policy, and community engagement can work together within one collaborative climate resilience framework. The projects eventually culminate within the California Center Digital Twins Hub, a public-facing platform where projects, reports, GIS systems, immersive environments, media, environmental visualizations, and educational resources are organized into one connected ecosystem. In many ways, the fellowship operates similarly to a tensegrity structure. In a tensegrity model, strength does not come from one dominant component, but from the balanced relationship between many interconnected parts. The same principle applies to resilient cities and collaborative education. These projects are not abstract exercises. They emerge from real neighborhoods, real environmental conditions, and real community challenges throughout Los Angeles. More than a fellowship, the California Center Digital Twins Initiative represents an evolving model for how education, technology, environmental stewardship, and interdisciplinary collaboration can come together to help shape a more resilient future for Los Angeles and beyond.